Okay, so now finally we're going to solve an exponential equation. And this will be our first example. It's not a complicated example. And the basic strategy that we're going to use to solve this type of simple exponential equation is that we're going to try to set each side to the same, we're going to try to set each side as a power of the same base, and then we're going to equate the numerators. This is basically we're going to exploit one of the important properties of the exponential, the so-called one-to-one property. Okay. So this is the one-to-one property of the exponential. If you have b to the x equal to b to the y, then the x is equal to the y. Okay. Now let's think about this situation here. If there is some way that I can write 128 as a power of 2, then I will be able to exploit this property. I'll be able to follow the basic strategy that I outlined earlier. Okay. That is, what is the earlier strategy? To set both sides as powers of the same base. Okay, so let's say 128. So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So I know 2 to the first power is 2. And then how would I get 2 to the second power? I'll just multiply this by 2. So this times 2 is 4. This times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. Aha! Look what just happened here. 2 to the 7th power is 128. You see that? Okay. So therefore here I can rewrite our given expression as 2 to the x equals 2 to the 7th power. And now I can exploit the one-to-one property of the exponential. Because from the one-to-one property of the exponential, right, I know that therefore our solution is going to be 7. Okay. Now, you might think to yourself, well, David, is that going to be all? Is that going to be like the cure-all and end-all for exponential equations? And unfortunately, as you all might be aware, it's not. So let's say we have an example like, let's say, 2x to the 5th power. 2x equals to 5. Now, you might remember the powers of 2 that I just wrote in the table, and you know that you cannot write 5 as a power of 2. But so in other words, this kind of solution cannot be, this kind of exponential equation, cannot be solved using this property, okay? At least not in the way that we're doing it, right? So, but what we are going to do is we're going to learn how to use logarithms, and using logarithms, we will be able to express the solution of an exponential equation like this, okay? And then finally, an example like e to the x equals x squared plus x minus 100, okay? Now, this kind of an equation, if it does have a solution, will not be able to be solved within the context of what we're going to learn in our algebra lectures. So this one, unfortunately, will be outside of our reach for an explicit solution. We will discuss how we can try to solve an equation like this, of course, though, but we're not going to be able to solve it explicitly. So, but in the next few lectures, in this section, we're going to do examples like this where we can solve explicitly for the solution. Yes. In any case, I hope you've enjoyed this little example, and I'll see you again soon. Thank you.